Question 1. How many different Social Security numbers are there if there are no restrictions? Well, Social Security number has, in its form, 9 digits. We have 3 first digits, then 2 middle digits, and then 4 digits at the end. Now, without any restrictions, we can have any number in any location, and we can have repeats. So if we think about this, each location, each digit, or each spot has 10 choices for that digit. Or in other words, 10 to the power of 9. Now part B says no number can begin with a 0. So we still want a Social Security number. We don't want to start with a 0. So really the answer for part A is the answer. The only thing that changes is that first spot. Can't have a 0 there. That means there are 9 digits that are available for that first spot. All the rest of the spots have 10 digits that can be in that location. So 9 times 10 to the 8th. Part C says neither of the first two digits can be 0. In this case, our first two digits both have 9 choices. All the rest have 10 choices. Question 2. How many different 7-digit telephone numbers can be put on the 501 area code? Well, the 501 area code is 501 followed by 3 digits and then 4 digits. That would make up those telephone numbers. So the 501 is fixed. We don't have any control over that. So really we're picking 7 digits. Now part A says no restrictions, so we assume that any number can be used in any location. 10 times 10 times 10, and then 10 times 10 times 10 times 10 gets me the last 4 digits, or in other words 10 to the 7th. Part B says no telephone number can begin with a 0, so 9 for the first spot, and then times 9, 10, 10, and then 10s for the last 4 digits, for the number of choices for those last 4 digits, I should say. Part C says no telephone number can begin with a 0, and the last digit must be odd. So 9 choices for the first digit. Our last digit has to be odd. That means it's a 1, 3, 5, 7, or 9, so there's 5 choices there. We haven't placed any restrictions on the middle digit, so each one of them have 10 choices. Question 3. How many ways can 5 boys and 3 girls be seated in a row? And part A says no restrictions. Well, the first thing to remember is if there are going to be more seats than kids, or less seats than kids, the problem will tell us that. So since we're just told we have 5 boys and 3 girls, that means there are 8 seats to work with. And there are no restrictions, so we can have any kid sit anywhere. So for this first seat, we have 8 choices. Now once that person's seated, they can't be in any other seats, so there are 7 choices for the next seat. And then 6, and 5 times 4 times 3 times 2 times 1. Another way of writing this is 8 with an exclamation point has 8 factorial. Part B says the boys and girls are seated alternately. Well, alternately means boy, girl, boy, girl. Now, I have 4 boys and 3 girls listed here, but I had 5 boys to start with. So if I place a boy at the end, in other words, boy, girl, boy, girl, boy, girl, boy, boy, This last little bit is not alternating, so that's not possible. If we started off with girls, notice there we have 3 boys next to each other, so that's not alternating. Alternating has to be boy, girl, or girl, boy, all the way through. So there's no way that this can be done. Well, if something is not possible, well, when you're asked how many ways can it be done, then the answer is 0. Part C, a girl must be seated in both end seats. So there's our 8 seats, and we want a girl to be in both seats at the end. Now, we haven't restricted which girl, in other words, all these kids have names. All we said is a girl had to be in both end seats. So this first end seat here, there's 3 choices because we have 3 girls. Whoever's seated there can't be in the other end seat, so there's only 2 choices. Now we still have 5 boys and 1 girl left to seat. Now there's no more restrictions on where the last girl can sit. She can sit anywhere in the middle. The 5 boys can be anywhere in the middle, so really we're not concerned about boys and girls at this point. We just have 6 kids left to seat. So 6 times 5 times 4 times 3 times 2 times 1, and then times 2 at the end. So that would be our answer. Now we can multiply these out easily enough on the calculator. If you multiply this out, this would give you 4320. Question 4. How many ways can 5 boys and 5 girls be seated if they are alternating? Well, we have 5 boys and 5 girls. That gives us a total of 10 kids. And we can alternate. We start off. I'll just write the alternating sequence underneath, so I'll remember my pattern. Girl, boy, girl, boy, girl, boy, girl, boy, and then girl, boy. Now this first seat, since I'm going to start with a girl, has 5 choices. The second seat has 5 choices because that second seat's now a boy. The third seat now has 4 choices because 1 girl's been used. Can't use that person again. The fourth seat, well, it's going to be a boy, but 1 boy has already been seated, so there are 4 choices. And following the pattern, we have that right there. But notice in this counting technique, I set it up with the girl happened first. That was an arbitrary decision. Notice we could have done boy, girl, all the way through and still alternated. So since we could have started off girl, boy, or boy, girl, I need to take this answer here and multiply by 2. The 2 being swapping the order of alternating. Now we could have also, on this problem, drawn out 10 blanks and said, okay, for the first seat, I have 10 kids who could be seated in that spot. Now, any one of the 10 kids could be in that location, whether a boy or girl. Whoever's seated there, if I picked a boy, then my next choice had to be a girl. There's 5 girls left. If I picked a girl the first time, then I had 5 boys left. And then I just followed the pattern of alternating. So both of those answers get you the same result. Now part B, boys sit side by side and girls sit side by side. Well, by saying the boys sit side by side, it's like taking the first 5 seats, let the boys be there. The next 5 seats, let the girls be there. Now if you notice, in the boys it's going to be 5, 4, 3, 2, 1. Now 5, 4, 3, 2, 1 is the same thing as 5 factorial. The girls is going to be 5, 4, 3, 2, 1. once again, 5 factorial. But notice when I did this, I set the boys first, then the girls next. We could have also swapped them, put the girls first, then the boys. So I need to multiply by 2 to count for the swapping. Part C, one of the girls, Sue, must be seated on the left end. Well, if Sue has to be seated on that left end, we have one choice for that seat. The rest of the seats have no restrictions. So 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, or in other words, 9 factorial. Question 5. In how many ways can 8 books be arranged on a shelf? Well, first of all, we need to look at this and say, okay, well, once a book is put on a shelf, can it be placed again? In other words, can we put the same book more than once on that shelf? The answer to that is no. So, in essence, what we have is that no repeats are allowed. Now, Part A says no restrictions. Well, got to remember that no restrictions within context of what we're trying to count. So I have 8 books I'm going to place on the shelf. So there's 8 blanks. Once I put that book on the shelf, it's already on the shelf, so I can't take it and put it back again. So I have 8 choices for the first spot, and then 7, 6, 5, and then 4, 3, 2, and 1. In other words, 8 factorial. Part B, one of the books of Mice and Men must be displayed on the left end. So that particular book is given a location. It's got to be on the left. So it has one choice for that spot. The rest of the books can be anywhere in on that shelf. So there are 7 choices for the next spot. And then 6, 5, 4, 3, 2, and 1. Or in other words, 7 factorial. Question 6. How many 3-digit numbers can be formed using the digits 2, 3, 4, 5, 6, and 7? Well, first of all, it says no restrictions. Well, we have a 3-digit number. Now, before we start filling things in, we need to think about what is a valid 3-digit number. So what does no restrictions mean? Well, what are our typical numbers? Notice that 222 is a valid 3-digit number. And the number 2, the digit 2, got used repeatedly. So with numbers, when you say no restrictions, that means you can have repeats. So no restrictions, we have 1, 2, 3, 4, 5, 6 numbers that we're picking from. So the first digit had 6 choices, the second digit had 6 choices, and the third digit had 6 choices. So if we multiply that out, we'll get an answer of 216. Now Part B says the numbers formed must all be even. Well, 3-digit number. Now for a number to be even, well, look back at the 222. The reason I know this is an even number is because the very last digit had to be even. So if I say my number has to be even, well, look at the digits I'm starting with. The 2, the 4, and the 6 are my 3 even digits. So this last spot has 3 choices. Now 574 is a valid 3-digit number that's even. So these first 2 digits can be anything they want to be. So each one of them has 6 choices. Part C, the numbers formed must all be even and no digit may be repeated. Well, so the most restrictive spot here is the last one, so I want to put that in there. So I have 3 choices for that spot. So either a 2, 4, or 6 was chosen in that last spot. Now because it says that no digit can be repeated, whatever digit I use in the last spot cannot be reused. I started off with 6 digits to choose from. I used an even one for the last one. That means I have 5 choices for the first spot. Now I've used something for the last spot, I've used something for the first one. Yep, 2 of those digits are gone. There are 4 choices there. Now if you don't fill in the most restricted spot first, you will get yourself into trouble in some of these other problems. So once you start getting restrictions, you always fill in that location first, because it will make life easier in the long run.